let's try to solve another Leetcode problem 37, find pattern in infinite string 2. And for this problem, we are giving a string. So this string is not an array, it is just an infinite string. And there's going to be a method next. So for example, if we just print out string.next, it's going to be the first number. So it's going to be this number 1. So let's just check what it is. So for example, I'm going to just return a random 0, and let's just check what is going to be the string.next. Yeah, so for the first example, it is 1, it is okay, and for the second example, let's just check it is 0. So this means we can use string.next, this method, to check the first integer of the string, because the string is basically 1, 0. Yeah, and we are also giving a pattern, so a string and a pattern. And we want to check the first pattern that is inside of the string. So for example, if it is a 0, 1, and this is a 0, 1, and we just need to return the index, which is going to be 3. So this is going to be the first index. And according to the description, the index must exist. So for example, in this one, it is 0, and the final result is going to be 0. And for this one, it is a 1, 1, 0, 1. So this is 1, 1, 0, 1. So it's going to be 2, 0, 1, 2. So the index is going to be 2. So if you read the problem directly, you can find this is going to be a string matching problem. You can use any kind of a string matching algorithm to solve the problem. And for me, I'm going to use the KMP to solve it. So basically for the KMP, we just need to prepare a next table. So let me just prepare a next table, and inside it is going to be a string s. So let me just finish the basic template for this next table. Yeah. So this next table just means we are going to check the prefix and the suffix. So for example, A, B, C, A, and this is going to be the next table. So this is going to be 0, 0, 0, because this A, for this A, the prefix is A and the suffix is also A, so this one is going to be 1. So this is just for checking the next table. The idea of the next table is that we can solve the problem by using O(m) plus n time instead of m times n. Yeah. So this is why we're going to use the KMP. Because we are giving this pattern, it is 10 to the power of 4, and the limit of the string is 10 to the power of 5. Definitely, we cannot use the m times n to solve the problem. We have to use m plus n. So this is why we're going to use the KMP to solve the problem. Yeah. Now let's just finish the table, the next table. So while j is more than equal to 0, let me prepare the next table. It's going to be basically an array. So inside I'm going to prepare a dummy space. It's going to be -1. So this is just for the calculation. So if you are familiar with the KMP, and if you are familiar with how we can produce the next table, basically you know how to write the algorithm. Yeah. So we're going to check the character if this si not equal to sj. So j gonna jump to next j, and then j gonna plus equal to 1, and the next gonna append this j. So by this way, we produced the next table. Yeah. Now the second step is that we are giving this string. How can we use this string to check the string matching? So this is gonna be the second step. Yeah. So the basic idea is that we're gonna prepare a j equal to 0, and we can copy on these ones. So this is going to be the basic pattern for the string matching while we are using KMP, and here this is going to be the pattern. So currently we need to prepare a pattern. So let's just prepare a pattern p gonna be empty, and for any number inside the pattern, so p gonna plus equal to string with this number. So currently we have the pattern string, which is gonna be on this p. Yeah. So here we're gonna change this si not equal to pj, and j gonna be equal to dot next. Yeah. And here we can check if this is j equal to length of the p, the pattern. So we can return I minus j plus 1. So this is the basic pattern while we are checking the string matching. But we cannot use this one because currently we don't have this string s, because currently it is a string. So we're gonna prepare an index I. It's gonna be starting from -1, and here we're gonna use a while loop to check. So while true, and we're gonna prepare a character C. So this is C gonna be equal to string dot next, because this is basically a iterator, and we can check the next character. Yeah, but we need to turn it into a string because we want to compare the string. Yeah, all the number it is the same, but I want to turn it into a string because this pj is I've turned pj to a string. So currently I need to turn this si to string. So here I'm gonna use this character c. Basically it is the si. And I also need to update the index I because I want to find where it is. Yeah. So j set into 0 and I set into I minus 1. This means for the first character the index I gonna be 0 because here is I minus plus 1. And here we have the pattern checking. If it is not equal, so j gonna jump to next j, and here is j plus 1. So if j equal to length of p of the pattern, so we're gonna return I minus j plus 1. Yeah. So that's all about it. It is basically yeah, because I think here I didn't prepare the next array. Let me put it here. So the next array gonna be the next of this pattern p. Yeah, because here we already calculated this p. Now as you can see it works. Now let me submit it. Yeah, as you can see it works and it's pretty fast. Although it is like more than 2 seconds, but it is okay. As you can see it's 100% because KMP basically we just use om plus n to solve the problem, and n is 10 to the power 5 and m is the pattern's length. It's going to be 10 to the power 4. And if you are not familiar with how to produce this next table, and you need to check the videos from the KMP. And basically if you are just search any kind of YouTube videos, what is the KMP, normally you should understand this kind of a next table. So basically this next table is prepared for us whether we need to jump. Yeah. So this means this is ABC if we are checking a pattern. So for example, this is maybe ABCD. Yeah. So here for this yeah, here this A is 1, B is 2, because ABC, this C gonna be 3, yeah, and this D gonna be 0. So this means if we are checking a pattern like ABCD, what are we gonna do? We're gonna check ABC, but B is not equal to A, but we don't need to go back to B to check one by one because this is the brute force. So what are we gonna do? We're gonna just shift this ABCD aligned with this A. Yeah. So now for the next, what are we gonna do? We're gonna check this A equal to this A, B equal to this B, and C equal to this C, and D equal to this D. Because only in this way it is m plus n. This is why we're gonna produce such kind of a next table. And next we just use the similar pattern to check the pattern matching for the stream. So I think that's all about it.